Now let's take a look at the following function. What's the domain of this function? The domain is the set of all x and y's or their pairs such that this guy is defined 2 over x plus y is defined. Well, since you have a quantity on the denominator, this guy can never be 0. So we're going to have the set of all x and y's in the plane such that x plus y is never 0. But what's the meaning of that? It means that line y equals to negative x must be excluded from the plane. So if we graph xy plane, the line y equals to negative x is located here. And since we're excluding this, we're using the dotted line. And where is the domain? The domain is all of the plane except for this line. That's why we're using the dotted line. So here you have the domain of this function. Now for the range of the function. To find the range, you have all z values. The function is defined as 2 over x plus y, or all output values such that the x and y, they belongs to the domain. So what's the meaning of that? It means that we are allowed to take any points except for the points located on this line. So our range is all z values, output values, such that z is never 0. Again, recall that in elementary calculus, you had y equals to, for example, 2 divided by x. How did we graph this? What was the domain? Domain is the set of all x values such that x is never 0. Well, what about the range? Remember the graph of your function. You have a reciprocal function. At 0, you're going to have a vertical asymptote. This is the line x equal to 0 that we are already excluded, all right, because it's a vertical asymptote. Then for your graph has 2 pieces. So as you can see, the output values are the set of all y values such that, well, your y value can never be 0. Your y value can take on positive values, can take on negative values. So these are the positive values that your y is taken, negative values that your y is taken, but it never gets to be 0. Y cannot be 0. In 2D, the input values are on x-axis, the output values are on y-axis. But in three-dimensional function, here you have your domain in xy plane and your range belongs to z. Let's take a look at the graph together. Let's take a look at our 3D graph using GeoGebra. So this is the behavior of your surface. As you can see, z never gets to be 0. Z can take on negative values, positive values, but no zero.